Welcome to my channel, AI Make Easy. In our last video, we covered the basics of how a neural network works. Now we're going to put that knowledge into practice and train a simple neural network to recognize handwritten digits using the famous MNIST dataset. We will train the neural network model with Jupyter Notebook. You may find the script in description below. The training flow of a neural network model is to prepare the dataset, train the model on the dataset, test the model on a dataset, and evaluate the model's performance. Firstly, we need prepare dataset by using command pip install torchvision and import the necessary libraries to download the MNIST dataset, which contains thousands of handwritten images from 0 to 9. At default, the data is split into a training set and a testing set in ratio of 6:1. The training set is used to teach the model, and the testing set is new data that used to evaluate how well it has learned. Splitting the data ensures that the model can generalize to new, unseen examples and isn't just memorizing the training data. We then unpack and save each of image locally with function save images. Once finished downloading, we need to set up the neural network model for training and testing. The network class defines the sequence in which a tensor is processed. In this case, the input tensor is first flattened. It then goes through a single hidden layer using a linear function and a ReLU activation function. The 28 × 28 represents the input image in tensor's size, and 256 represents the number of neurons in the hidden layer. Similarly, the 10 represents the number of neurons in the final output layer. Besides, the forward function defines how the input data flows through the network. In our case, it first flattens the tensor and then passes it through the layers we defined. The forward method is implicitly used whenever we pass an input tensor to the model instance. We don't need to explicitly call this function. Now we proceed to feed the training images into the neural network. In this train function, we feed a batch of training images to the network, and to save time, this training function converts the images to grayscale before feeding them to the network, as color is irrelevant for number recognition. Then we import the training dataset with a data loader and enable the shuffle feature. This randomizes the order in which the training images are fed to the model. And this line tells the program to use the sequence of layers we defined earlier. The model makes its predictions and then compares these predictions to the correct answers. If the model is wrong, it adjusts its internal settings to reduce the error. This entire process is repeated until the specified number of epochs is reached. Ideally, the loss should be decreasing with time, and it should be minimized. For example, if the network predicts 7, but the image is actually a 1, the network adjusts its internal connections, the weights and biases, to reduce that error. This process is repeated thousands of times, or epochs, until all the epochs reached. After training, we test the model using the unseen testing set and get the accuracy score. This gives us a realistic measure of its performance. For this case, our model achieves 98% accuracy on the test data, so we can say that it's highly reliable and ready for use. This trained model can then be used to recognize handwritten digits in new images. Now we can test the model with a randomly selected image using this function. Just like the train and test functions, the image will be pre-processed and fed into the trained model, which will then print out its prediction. With the show image function, we can display the image we selected for testing, and as you can see, it successfully identifies the number. You can also run a batch image testing on the model to get its overall score. All of the related code is attached in the description below, so feel free to check it out. I hope this overview helps you understand the fundamental concepts of neural networks. Thanks for watching. I hope this video was a helpful step in your AI journey. If you found it valuable, feel free to like and subscribe for more content. Thanks for joining me today.